This is a big need. They have legacy data, or they get 2D data from customers, and they need to convert it to 3D without actually recreating it. So here's the secret to doing it in SpaceClaim. First, I showed you that trick before of copying and pasting things. I love using that. I mean, I use Windows every day. Most of you guys do. I like to just kind of start over fresh and paste all the different things I need in a new document. So I've done that. I took just the views that are relevant to me and put them in a brand new document. Here's the way SpaceClaim lets you turn it into 3D. Any of those closed loops of sketches, when I go into a 3D mode, we turn those into surfaces automatically for you. Now, I'll just mention this, but don't have time to show it. A question that comes up is, what happens if I don't have a closed loop of sketches? What if my DXF or DWG data is dirty? We have taken care of that too. Under the Repair tab, we will fix curves. There's different ways to do that. One of the great things is curve gaps. We'll find little gaps between curves where they're not joined together. Maybe someone drew it wrong, a bad translation. It was translated from a PDF file. We will fix those with our fix curves tools. Now, back to the task at hand. I need to turn all this data, or I need to use all this data rather, and turn this model into 3D. You know, like I said, we will take these sketches and turn them into surfaces for you. And the surfaces I can easily manipulate to use and put in strategic locations so as to turn this thing into 3D. These surfaces are not related to each other at all, nor were the sketches. It just comes in as dumb geometry. But the key is, SpaceClaim, we take dumb things, dumb geometry, right, and we'll let you modify it, manipulate it any way you want. I'm taking this channel, this section, this surface at the end, using the pull tool. And in just a couple seconds, I basically have the overall shape of this. Now, I inadvertently selected a couple extra things I didn't mean to, and I've got a strange solid down at the bottom. That's okay. You don't really make mistakes in our software. If you do, you just go delete it or undo it. I hit delete in the keyboard, and I'm done. Now, I want to create the rest of this model, because this is just a simple U-shaped extrusion, but there's a lot of cutouts in it, and I don't need to go sketching on things. I'm just utilizing the data around me. But I'm going to do it, again, with a little bit different approach than what you might think and what you might be used to. I'll create a brand new solid running right through that part. Now, let me change the colors to make it apparent what I'm going to do. Basically, anything that you see in green right now, I need to remove. And anytime the green intersects the orange, that's material I want to keep, right? So I use the combine tool to handle this. Again, simple workflow where I say what body it is I want to cut up and what body needs to do the cutting. I don't need that big block anymore. It did its job of cutting up the model. And it conveniently puts me in a mode, the system puts you in a mode now of deleting the bodies you don't want. And look at that. Before you know it, I've got a part that's very much looking like the real part. There's still a couple features I need. There's still a couple things in the mix from this bottom sketch that I'll need to utilize so as to get this thing looking correctly. And I'll move this sketch up just a little bit to make it easier to see when I make the cut. I've got some holes, 3 holes, 2 circular and something that looks more like a trapezoid. So I use the pull tool. Pull that straight up and make my cutout. No sketches, just utilizing the data around me. Now at this point, okay, there's a bunch of other things in here I don't need. Let's just delete some things from the tree and make this easier to see, all those extra surfaces and the curves as well. All right, that looks better. At this point, this body is behaving like a solid, meaning if I pull on it, I'm getting solid-like behavior. But hey, this is sheet metal, right? I don't want that to happen. I want uniform thickness. So what I'll show you in sheet metal is how I can convert any solid that's of uniform thickness to sheet metal. I click on it, and SpaceClaim recognizes that it's now sheet metal. You see the bends turn purple. When I pull on something, it behaves accordingly. It gives me the same wall thickness everywhere and just offsets that face. You know, I've been pulling on faces, left and right, up and down, but I haven't really shown you what happens much if I pull on edges. Well, in a sheet metal mode, I need something different to happen than if it were a solid. If I pull on an edge in sheet metal, it knows to make a flange for me. And that's exactly what I'm doing right here. I'm making that flange, and I need it to extend the same length as the flange down, or where that sketch is down below, that surface is below. So now that is correct. It's the same length as what that sketch shows. So in a matter of seconds, I'm able to get not just a 3D model, but an actual sheet metal part that you can actually flatten out. And I'll show that to you here. I click one button, unfold, and we are hands down excellent. I'm not ashamed to say it, excellent at flattening things out. If there's any problems in the model, if 9 out of 10 bends can be flattened, we will flatten those and show you what's incorrect. We're not just going to give you an error message and leave you hanging. In this case, you know, the entire model does flatten out just fine, but that's a discussion for another day. The point is, if you need to make, as part of your process plans, converting 2D data to 3D, if you have sheet metal you need to flatten out, you can do that here in SpaceClaim.